do realise, and you'll realise this tonight, that it's not just geeky creationists that are saying these things, but atheists who are incredibly clever and have no advantage to say these things are saying them. You realise that we're onto a winner. That actually there can only be one answer to how life came on earth, and that was through God. Psalm 139. We've read them many a time. Psalm 139, 13 to 16. David, isn't it? You formed me in my inward parts. You covered me in my mother's womb. I will praise you, for I am fearfully and wonderfully made. Marvellous are your works, and that my soul knows very well. My frame was not hidden from you when I was made in secret, skillfully wrought in the lowest parts of the earth. Your eyes saw my substance, being yet unformed, and in your book they were all written, the days fashioned for me, when as yet there were none. And then he goes on and he says, how precious are your thoughts to me, O God. Goes on, showing just how much God loves us. He thinks about us all the time. Well, let's just have a look at this, because you know, we are always at the mercy of the translators. When it comes to Hebrew and Greek, we always are. And they are at the mercy of what they know. So, of course, I think there's a few things in this that would make more sense today than they did 3,000 years ago. So press it down one, Kevin. It uses the word cover in verse 13. The word cover in the Hebrew is to entwine. Entwine. Now, the reason why I showed you the first video that I showed you, did you see how DNA was entwined? It's incredible. Book, word book or scroll, you might have scroll. It means a decree of instructions written in a curled up scroll. A curled up scroll. That's what it was. It was curled up. And when you look, this is a picture of the human body. David's talking about the human body here. And we keep coming across this phrase, written instruction that's curled up, entwined. What else we got? The word substance, verse 16, means the embryo. The instructions for the development of the embryo are determined, it says here, by what is written in the curled up scroll. You see that? Yeah. The instructions of the embryo are determined by an instruction code that is curled up. Next one. All my members are written. The word written means information that prescribes or directs. That is exactly what goes on inside of DNA. Okay, Kev, and again. The word fashion comes from, I don't know how you pronounce that, is it Yatzva? Which means something that comes into form according to a predetermined plan. Well, we know that about DNA. It's a predetermined plan of everything that you're going to be. Okay? And again. This is how somebody interprets Psalm 139, these few verses, if it was written today. God has a scroll with prescribed instructions that determine the development of my body, this is David talking, of my body, with all its members in their proper sequence from the embryonic stage until maturity, DNA. What you see in Psalm 139 is that within a curled up scroll is determined everything that we're going to be from birth through to death. And that's exactly what you see in DNA. And in the Hebrew, the term is curled up, entwined. This portion now is perhaps the best way of describing the ridiculousness of spontaneous generation.
Proteins are what you get when you string amino acids together, and we need a lot of them. No one really knows, but there may be as many as 1 million types of protein in the human body, and each one is a little miracle. By all the laws of probability, proteins shouldn't exist. To make a protein, you need to assemble amino acids, which I'm obliged by long tradition to refer to here as the building blocks of life. In a particular order, in much the same way that you assemble letters in a particular order to spell a word. The problem is that words in the amino acid alphabet are often exceedingly long. To spell collagen, the name of a common type of protein, you need to arrange 8 letters in the right order. To make collagen, you need to arrange 1055 amino acids in precisely the right sequence. But, and here's an obvious but crucial point, you don't make it, it makes itself, spontaneously without direction. And this is where the unlikelihoods come in. The chance of a 1055 sequence molecule like collagen spontaneously self-assembling are frankly nil. It just isn't going to happen. To grasp what a long shot its existence is, visualize a standard Las Vegas slot machine but broadened greatly to about 27 meters, to be precise, to accommodate 1055 spinning wheels instead of the usual 3 or 4. And with 20 symbols on each wheel, 1 for each common amino acid. How long would you have to pull the handle before all 1055 symbols came up in the right order? Effectively, forever. Even if you reduce the number of spinning wheels to 200, which is actually a more typical number of amino acids for a protein. The odds against all 200 coming up in a prescribed sequence are 1 in 10 to the power of 260. That is 1 followed by 260 zeros. That in itself is a larger number than all the atoms in the universe. Proteins, in short, are complex entities. Hemoglobin is only 146 amino acids long, a runt by protein standards, yet even it offers 10 to the power of 190 possible amino acid combinations, which is why it took the Cambridge University chemist Max Perutz 23 years, a career more or less, to unravel it. For random events to produce even a single protein would seem a stunning improbability, like a whirlwind spinning through a junkyard and leaving behind a fully assembled jumbo jet, and the colourful simile of the astronomer Fred Hoyle. Yet we're talking about several 100,000 types of protein, perhaps 1 million, each unique and each, as far as we know, vital to the maintenance of a sound and happy you. And it goes on from there. To be of use, a protein must not only assemble amino acids in the right sequence, it must then engage in a kind of chemical origami and follow itself into a very specific shape. Even having achieved this structural complexity, a protein is no good to you if it can't reproduce itself, and proteins can't. For this you need DNA. DNA is a whiz at replicating. It can make a copy of itself in seconds, but can do virtually nothing else. So we have a paradoxical situation. Proteins can't exist without DNA, and DNA has no purpose without proteins. Are we to assume then that they arose simultaneously with the purpose of supporting each other? If so, wow. And there is more still. DNA, proteins and the other components of life couldn't prosper without some sort of membrane to contain them. No atom or molecule has ever achieved life independently. Pluck any atom from your body and it is no more alive than is a grain of sand. It is only when they come together within the nurturing refuge of a cell that these diverse materials can take part in the amazing dance that we call life. Without the cell, they are nothing more than interesting chemicals. But without the chemicals, the cell has no purpose. As Davies puts it, if everything needs everything else, how did the community of molecules ever arise in the first place? It is rather as if all the ingredients in your kitchen somehow got together and baked themselves into a cake, but a cake that could moreover divide when necessary to produce more cakes. It is little wonder that we call it the miracle of life. It is also little wonder that we have barely begun to understand it.